All righty, good morning, guys. This is Wednesday for ACA. We're talking about the distributive property. We already talked about in my class what the word distribute means. We had people saying like to give out, to pass out. Someone said like when you're talking about groups, and I agree with all of that. You distribute things evenly amongst groups. And we can apply that word. There's actually one more property. The last 2 days we talked about 4 properties. Let's talk about what were those 4 properties. What was one of them?
Identity.
The identity properties, the inverse, right? The associative, Kyle, commutative, okay? So those are the 4 we talked about in the past. We have one more to add to it, which is the distributive property. It has to do with groups of things. It has to do with giving out things. Okay, so we have some real world examples because this is actually something that these properties are actually very much real world things. So let's say we are going to see the most recent Avengers because, you know, the 20th one is the newest and bluest, but it's all over again. Anyways, we are at the movies with our friends, with our family, with someone, okay? And you go up to the concession stands, and you know how they have those like combo deals, like, oh, a number 2 is like 6 drinks and 1 popcorn. Yeah, okay, I know it's not that much. But usually you say, okay, I want 4 number 2s or 6 number 1s or something like that. Y'all know what I'm talking about? Or you go to like McDonald's or Chick-fil-A, like Solomon, and you order like a combo. So let's look at this. So it's saying I'd like to buy 2 number 1s, please. Okay, and so what this picture is what's in a number 1. So what do we see? I see 1 popcorn and 2 Cokes. Okay? If I want 2 of those, okay, I'm going to draw it out. So that's one of them. I want another number 1. So I need another popcorn. I'm going to draw a box with P in it. Are y'all okay with that? Okay, y'all can draw it on yours as well. And then a Coke. I'll make it look different. I'll draw a triangle, a circle for Coke. Are y'all good with that? Right, I'm not about to spend my whole time drawing pretty pictures, but that is what's happening. So if I wanted to figure out what I had in total, okay, I want to group the things that are similar with something similar. I can't just say, oh, I got 6 popcorns and Cokes, right? But that's not good, and I'm not about to pour my popcorn. I'm not mixing my popcorn and my Coke. That's disgusting. Okay, exactly. So let's combine like with like. So I have how many popcorns in total?
1, 2.
I have 1 popcorn. I have 2 popcorns, right? I have 2 popcorns. I'm going to use the 2P. I'm going to use P for popcorn because I don't want to write it out. And then I also have 4 Cokes, 4 P's. Do y'all agree with that?
Yeah.
Yeah. Does that make sense?
Yeah.
Okay, because I should, when you say, okay, I want 2 number 1, what is that going to look like? I should get a total of 2 drinks and 4 popcorns. Splitting it amongst people. Okay? So this is very much, we can sort of, I know no one would go to the movie theaters and write an equation for this, but to make sure that you actually get it, you can actually do some math with it. Okay? So I wrote the expression, I want 2 combos, 2 number 1s. This one, you with me? I want 2 number 1s. Now what a number 1 is 1 popcorn and 2 drinks. Do y'all agree with that? Okay? Now, let's switch our gears to math. When that 2 is next to everything in the parentheses, what operation is happening with this 2? Very good, Lana. It's going to be multiplication. Multiply. Okay? Do y'all agree with that statement? Now, the order of operations tells me that I need to do what's in parentheses first. So I need to add the Coke in the popcorn. Now, we just said, is that something that we do? No, okay? So sometimes in order of operations, there's going to be 2 things that we can't combine because they're not similar things. They're not like terms, okay? And I'll show you how we can apply that to math in a second. But we're not going to add those 2. And there's a way we can work around the order of operations but still get the same answer. And the way that we do that is we say, okay, I'm not going to add those 2 numbers. Another way I could do it is I'm going to do 2 times the 1 and then 2 times the 2. I'm going to give out that 2. I'm going to distribute that 2. Okay? And I'm going to multiply. Okay? I'm going to redraw those arrows over here. Again, I'm going to distribute the 2 And by that, I mean I'm going to multiply that 2 times each of the numbers. Okay, so let's do that one thing at a time. If I do 2 times 1 popcorn, how many did I end up with? 2. I ended up with 2 popcorns. And if I do that math, 2 times 1 is 2. Now, I also need to give it out to the other thing, because I need 2 of this as well. So I need 2 times 2 classes, 4. So I should also have 4 drinks. Do you see how like the math also relates with it? That kind of stuff? And in total, I should have all those items. So with 2 number 1s, I bought 2 popcorns and 4 drinks. We agree with that statement? All right. Yes, ma'am. Okay, so let's do one more example, and then I'll let y'all do another one on your own. Okay? Next question, it says, I want to buy 3 number 2s. Okay, so this is 1 number 2. We need how many of these? 3. Okay, so if that's 1, how many more popcorns am I going to have? Well, that's a popcorn or popcorn. And then I'll draw a rectangle. So that's 1 number 2. This is another number 2. Do I need to do another one, or is that it? Another one. Okay. Okay. So that's 1 number 1. That's 2. That's 3. It's 3 groups, 3 combos of the number 2. So before we do the math, let's just count up like with like. Again, am I gonna go put in my M&Ms and my popcorn?
No.
I've done it before. It is actually pretty good, but realistically, no. Okay, realistically, no. So let's just count up how many popcorns do I have in total? 6. I have 6 popcorns plus 9 M&Ms. 9 M&Ms, and I'm just putting it in for M&Ms. We agree with that?
No.
Okay, let's look at the math of it. Okay, so again, I want how many combos? I want 3 of the combo number 2. Now, in parentheses is what's inside that combo. So in that, just one of those combos, it was 2 popcorn. So I'm going to put 2P plus 3 M&Ms. Okay. Okay, I'm going to copy that over. Again, 3 groups of 2P plus 3M. Now, again, I can't follow the order of operations, but I can still work my way around. I can't add those 2. Instead, I'm going to distribute that 3. So what operation am I going to do? Multiplication. Now, I want you to draw these arrows that I'm drawing. One of the biggest mistakes that 6th graders do is they forget to distribute to both of the things. They'll just do it to 1. And do you think this idol wants all 9 of her boxes of M&Ms?
Sure, yeah.
I do. Okay, if you don't distribute that 3, I'm going up to that cashier and be like, man, I'm gonna give you a whiteboard. I'm gonna draw out my picture and be like, this is what you owe. Well, excuse me, if I pay for all that, I better get my 9 boxes of M&Ms. Don't rip me off, bro. I'm going to yell you back. Okay? Don't do it. All right, pause. Here we go. What operation is it again? Multiplication. So we need to do 3 times 2. That gives me 3 times 2 gives me 6 popcorn. Okay. Mistakes happen. We're good. Okay. And again, we're going to do what with this 3 again? We're going to multiply 3 times 3. Very good, Cameron. 3 times 3 gives me 9 what? 9 minutes. Isn't that match our model? Bam, boom. Okay, so again, this action is called distributing. It's the distributive property. It's saying that writing this statement is exactly the same as this statement, just distributing that 3 out. Do y'all see how it sort of ties together? All right, do that next one on your own. It says, I'd like to buy 2 number 3s. I gave you 1. What does the second one look like? And try and do that math. Pause and play when you're ready. Sorry, I forgot to do the I bought. So on this first one, I bought 6 popcorns. Not 12. Not on this one. And 9 M&Ms. Ooh, that's a big deal. All right, So, Lana, you're doing it right now. What you get? 6 Coke, 4 M&Ms. Do y'all agree?
Yeah.
Let's draw that model just in case. It does not matter what shape that y'all draw. So I need another. So that's 1 10. Again, I always like to put my parentheses around my groups just to like collect it to do those groups like Brody was talking about earlier. Okay, so that's my Coke, Coke, and then another 2 M&Ms. Okay, in total, I have 6 Cokes, 4 M&Ms, but I'm going to do the math just to check. I would like 2 groups of, what am I going to write in here? 2 groups of 3
and 2.
And then 2 what, Brody? 2 M. Okay, again, I'm just rewriting. And what am I doing with that 2? What's that word that I used? Distributing, which is the action of multiply. Very good. Okay, am I going to multiply 1 or both? Both of them. Distribute it to everyone. Again, if I'm giving out candy, if I'm distributing candy, do you think all of y'all want it? Yes. Will I hear about it if I go? Yes. Okay. All right, pause, 3, 2, and 1. So, 2 times 3 gives me 6 C's, and then 2 times the 2 gives me 4 N. Okay, so I bought 6 Cokes. Oh my God, all the sugar. Y'all on Fun Food Friday. 6 Cokes and 4 M&Ms. And then they'll never share with the class.
You never share with us.
Sorry. All right, here we go. Next page. Open it up. Next page. Okay, of course, it's sadly, I know it's a true travesty. We're not always going to be able to draw pictures of Cokes and M&Ms, and we're just going to focus on the math. But it can always be there in your head. Okay, the popcorn and the Coke pop. But there's still other models that we can use. So I'm going to show you some other models that we can use. All right, so here we go. Distributive property. We said that to distribute means to give out. Or to give out. But it also means to multiply, as we just talked about. When using the distributive property, we multiply the number on the blank of the parentheses with each term on the blank. What do y'all think? The term on the, okay, let's go look back. I multiply the number on the outside with everything on the inside. The term on the outside tells you how many groups to each term on the inside. That says inside part. Okay, you're writing with me?
Yeah.
Outside of the parentheses to each one on the inside. So we use the distributive property to find equivalent expressions. Have we said that word a lot lately? Yes, Miss Lyle. Okay, because all of those properties with like the commutative, we said that 3 plus 2 is the same thing as 2 plus 3. That's an equivalent expression. The distributive property is an equivalent expression. It's the same thing before and after, if you do it correctly. It is useful when we need to multiply a group of terms being added or subtracted. Okay? Again, we're going to do some more models, but I'm going to show you how you can do it, like, just with what you have in front of you. I'm going to hand out at home, y'all don't have algebra tiles, but I'm going to use these little things that you can use here. Y'all can always use it on a test or quiz, but you can also write them out. So just give me a second to pass it out. All right, so guys, in your algebra tiles, and I'll try and vocalize this for everyone at home, you have 2 types of shapes. You have the long rectangles that you see are what colors? They are green and red. If you remember the counters that we used at the beginning of the year, the red means negative, okay? That's always going to be the case because all of them will have a red side. It will always be negative. Whatever the other side is will be positive. So the green is positive, yellow is positive, okay? So the long greens, those are positives, and then the small yellows are also positive. If anything is only one color, that means these are all good. These are broken like the counters, and I already said that. No, on both sides, they're not the same color. They're either yellow and red or red and yellow. If there's any broken ones, then those, if y'all will set to the side, those are just broken colors. Okay, so for those of y'all at home, we have these little things. they look like this. There's the long rectangles and the small little squares. Now, these are probably new to y'all, and we are going to use these to help us model, and I'll show you how. So let's look at this problem together. It says example with addition. It says I want to distribute the two. So are y'all looking at this, or are y'all looking at the house? Eyes up here. Up here. Okay, so it says 2 times 5 plus 3x. So let's talk about that. I like the model first. I'm going to write over here, so let's get our pencils. The way that you can like say this expression in your head is 2 groups of 5 plus 3x. Okay, 2 groups of 5 plus 3x. All right, so let's start with the model, okay? I need to do 2 groups of 5 plus 3x. Let's start with just what one group would look like. Now, I noticed that inside the parentheses, there's one term, okay, that's just 5, and there's one term that has x's with it. So that's where our different pieces come into play. What one group is going to be the 5. When the 5 is just on its own, it's going to be these little pieces. That just represents 1, a positive 1 or a negative 1. And these long sticks represent the x values. Again, x, do we know the value of x? No, that's the whole point. It's unknown. So that's why they're different things, because we don't want you to get them confused. So if I'm going to model 2 groups of 5 plus 3x, let's start with the 5. I'm going to do 1, 2, 3, 4, 5. Okay, pause there. Again, if you're at home, you're just drawing the model. If you're in class, you can actually model that out. They would be 5 what colors? They would be 5
yellow.
Yellow, very good, because they are positives. All right, so that's 5. We still need to do plus 3x. So I need 3 of those long rectangles. So I'm going to do 1, 2, 3. Now I know sometimes our rectangles sort of mesh into looking like squares, so I always like to put an x in my x's. Okay. Do we agree that is one group of 5 plus 3x? Do we see it? Sort of, kind of? Yeah. But for this problem, I don't just need one group. I need 2 groups. So I'm going to copy and paste. It's like, you know how you copy and paste on a computer? I'm going to copy and paste that same thing. I need another group of 5 plus 3x. So 1, I'm doing it in different colors. 1, 2, 3, 4, 5, and then 3 x's. 1, 2, 3. Again, I had to switch a few, so I'm just putting x to clarify that it's an x. Yes, ma'am.
Do you have to put an addition?
You don't have to. You don't have to. Okay. I'll show you where like negatives and subtraction come into play in a second. Yes.
We don't do some multiplication.
I'm sorry?
We don't do some multiplication.
So the multiplication is coming into the 2 groups part. Okay, and drawing it out in the copy and paste, we are doing that multiplication. Now let's collect like with like. Can I say that the x's, can I say those long rectangles are the same as the little tiny squares? No. Okay, so I keep them separate, I combine like with like. So how many of those tiny squares do I have? 10. And then how many x's do I have? 6. Again, everything's positive and plus because I'm only dealing with positives right now. Yes? It's not exactly, and so that's why it's just an unknown value, and you don't want to think of it as 5 because x isn't always 5. So let's not do it that. All right. Of course, we're not going to like. How many of y'all want to draw that out? If the model had 10 times 5 plus 3x, how many of y'all would actually want to draw that out? Nope. Exactly. So let's focus now transitioning into the math of it. So I need to distribute. Distributing means to what operation? Multiply. Very good. I'm going to multiply. I'm going to draw my arrows. Please draw your arrows. Basically, what I'm going to do is I'm going to do 2 times 5, and I'm also going to do, I'm going to add that to 2 times 3x. I'm taking baby steps so you see the whole path. Okay, fill in those boxes. I see people without pencils. I see people without pencils. Yeah, okay. And now let's actually multiply. Class 2 times 5 is? And 2 times 3x would give me 6x. Can I combine that last step?
No.
No, because again, talking about that model, I cannot combine my squares with my rectangles.
You can't put letters with numbers.
Repeat that?
You can't combine letters with numbers.
Correct. I can do, when it's just, it has those letters. If it's multiplying, that's one thing, but I cannot add those two. Okay?
Yep.
Let's do another one. Predicting. What do I already see in that next equation that we want to see? A negative, or it's actually a subtraction sign. Okay? Let's talk about it. Let's first do the words. Try and guess. What do y'all think the words would be? Three groups of what? X minus 4. Very good. 3 groups of X minus 4. Awesome. Okay, let's start with one group of X minus 4. Let's start with one group of it. Okay, how many rectangles do I need?
One.
X minus 4, I need 1x. And then minus 4. Okay, so with subtraction, someone already said it, another way of saying minus 4 is I could also rewrite that to plus negative 4. So instead of 4 yellows, I'm going to do 4 red tiny squares. So I'm going to draw my tiny squares. I'm doing 4 of them, but because it's minus 4, that's the same as adding negative 4. So I'm going to put a little minus sign to show that they are negatives. Okay, I don't see pencils moving for some people. That is one group, but I need, oh, no, 3. We said 3. So I need to copy and paste that twice. Make sure you mark those as negatives. If they're not negative, you'll forget. I promise you. Okay? All right, let's combine light with light. I have how many X's? 1. Oh, no. In total, I have 3 X's, and then 12 negative. So how can I, there's 2 ways I could write that. I could say,
Comma negative 12.
no, I don't want a comma in my equation.
Sorry, I mean parentheses.
Okay, parentheses of what?
Negative 12.
I could either say like plus in parentheses negative 12, or I like it better because it's more simplified. That's the same thing also as 3x.
4. Negative 4.
What's another way of saying plus negative 12?
Minus 12.
Minus 12. I like the version of 3x minus 12 even better. I would accept either one for y'all. Okay? And we'll practice this as we go. Technically, they are both correct. This is the more correct. But I would give y'all full credit. Okay? So, of course, let's do the math. First, we like to, like the notes, they know me so well. I don't like subtraction. I like adding the opposite. So I'm going to first rewrite it. 3 groups of X minus 4 is the same thing as 3 groups of X plus negative 4. Again, subtraction throws me off, so I like saying that adding the opposite. Okay, and then I'm just going to copy this right here. 3 groups of X plus negative 4. To distribute means to multiply to both terms. Draw your arrows. Those arrows are a visual reminder. Did you do this one? Did you do that one? Check. Okay, and I'm just going to rewrite that. 3 times X, and then I'm going to do 3 times negative 4. Okay, now let's actually multiply that. 3 times X just gives me 3X plus 3 times negative 4, because signs are different, negative when that's 12. Okay, that is technically correct, but I can simplify because I can rewrite that. Plus and negative is the same thing as just, very good, it's just the same thing as subtraction. Okay?
Yep.
The rewrite is probably the least of my concern. It's still a concern, but it's at the bottom of the list. The top of the list is making sure you multiply both terms. Okay? So, okay, yeah, let's just practice rewriting. So, if I see plus negative 10, how could I rewrite this? 4x plus negative 10 is the same thing as 4x minus 10. I keep the first one and add the opposite. Okay, let's try that next one. Rewriting negative 4x plus negative 10 is the same thing as negative 4x minus 10. You got it. Remember, y'all always said like keep, change. It's the same thing back. If you want to do it back, still keep the first one. Change the second thing. You're changing it to subtraction, changing it to the opposite. It's that same thing helps you. Okay? Rewrite, add the opposite as subtraction. Just plain old subtraction. Okay? So, I'm going to let y'all do a few on your own just to let it sink in and so you don't have to hear my voice. I know it's your favorite sound. Okay, so I know you're a bit confused, and that's why I'm going to let y'all practice on your own. So we're going to come back to that bottom, but flip over. I want y'all to at least do these top two and these bottom two on your own. Do the top two. See if they're the same. Ready, set, go. I saw some people stuck, so let's put the words. I saw the words were good. We said for this first one, it's 2 groups of x plus 4. Awesome. Okay? This modeling is how we can still help ourselves out. First, I'm going to draw one group of x plus 4. Tell me how many rectangles and how many little squares I need. Brody, how many rectangles and little squares do I need?
4.
For what?
Is it square?
4 squares, I agree, that's part of it. Is that all of it?
No.
No, what else do I need? Okay, so we said that the x's are just a rectangle. How many rectangles do I need?
1.
Just one. And again, I like to put a little x as a reminder that those two things are different. Do we agree that's one group of x plus 4?
Yes.
I need how many groups of it? 2. So copy and paste. It's not 8. Someone keeps saying 8. Part of it is 8, but the whole thing is not just 8. Combining like with like, I have, Hudson, what do I have in total? I have
10.
No, because those aren't all the same. Okay, these rectangles are not the same thing as those squares, so I can't combine them. It's like my popcorn and my Coke. I can't combine them. So, like with like. How many x's do I have? I disagree with that. I have 2 x's, very good. And then how many of the other things? Plus 8. And that's it. Because again, the Coke and the popcorn have to stay separate. I cannot combine. The reason why I cannot combine, for the math reasons, that x is still an unknown value. I still have to follow the order of operations and multiply 2 times whatever that number is before I can add. The rules of order of operations still say, I have to multiply before I add or subtract. Okay. Over here, do I have any groups of anything? No, it's just
2x plus 4.
Great. 2x plus 4. 2 x's plus 4. 1, 2, 3, 4. In total, I have 2x plus 4. Now, let me ask you a question. Are these two things equivalent expressions? Are they equal expressions? Do they show the same thing?
No.
Jackson, why are you shaking your finger saying no?
Because, first of all, I know, of course, there's more models that will be more something,
Yeah.
and then whatever they're counting in the.
Very good. Okay? These are not Very good. These are not equivalent. The reason he said is because those models don't match, and that's completely correct. Okay? A very big thing. Looking at those numbers, they look very similar, but with those parentheses, it's talking about groups of something, so it actually is multiplying how much is actually there. So you actually have to distribute that 2 and get your final answer, and you say, that's plus 8, that's plus 4. There is a difference. Okay? I'm going to do one more with y'all. Down here at the bottom, because it's a little bit of weird. Because what do we see? We see a fraction and 1/2. How do we model that? So I'm going to do, let's guess the word. That could be half a group. Half group of x minus 4. Half of a group of x minus 4. I'm still going to start with that group of x minus 4. How many rectangles do I need?
1.
1. And I need how many squares? No, with what I'm starting with 4. And those 4 little squares are going to be negative because it's subtraction. Now, I still haven't done the half part. Okay, I need half of this. So how much of the x am I going to need? Half of this. How do we get half of something? Divided by 2. So it's going to be, a way to do this is half of 2, x divided by 2. Or you could also say half of, you could do half of x, or you can do half of x. And then what's half of the negative 4?
Sure.
What's half of this? Negative 2. Negative 2. Okay? There's people who have sort of checked out. It's going to be hard to do the homework tonight. We have a quiz on Friday. This is going to be on it. We do have a quiz. Okay? So, here's a few more minutes. Let's go back and let's just try this without the modeling, because maybe we're at a point where the modeling just starts us off. Okay, and that's fine. Let's just get to the plain old math. Okay, to distribute means to do what operation? Multiply. So draw your arrows. Ready? Go. Okay, on this first one, I'm doing 6 times x plus
5.
6 times 5. I have to give it out to both. Remember, if I don't give my thing out to everyone inside of my classroom, inside of that parentheses, someone's going to get mad. 6 times x is the same thing as 6x plus 6 times 5 is 30. On the next one, what's different? The multiplication is at the end. Is it still showing to multiply?
Yes.
I'm still going to multiply. I'm just going to distribute. It's the same thing, it's just from a different direction. Okay, so I'm going to do, this first one is going to be 2x times 7 plus 10 times 7. And again, you can switch that because it's multiplication. 2x times 7, 14x plus 70, because it's 10 times 7. Okay. Next one, I see that evil operation of the subtraction, so I'm going to rewrite it to, I'm going to keep the 2, and then instead of r minus 4, I'm going to say r plus negative 4. Next step, what do I need to do? I need to distribute. So 2 and r, and then 2 and negative 4. Two times r is 2r. Okay, bring down that plus. 2 times negative 4. Sorry, it's already.
Signs and
Signs are different.
different negative.
Very good. So it's going to be a negative. Very good. Okay. Adding a negative is the same thing as subtraction. So that's going to be the same thing as awesome. Okay. You have to practice this one. This one is a weird one. That's why you have a whole day and tomorrow just on this property because it's a special little potato. I know it's weird on the first day. Okay.
Special potato.
It's a special potato. Okay. Pause. Pause. I have like one more second with y'all. Distribute it out. Even if the negative is on the outside, I'm still going to multiply. Negative 4 times 3x plus negative 4 times 8. Negative 4 times 3x signs are negative wins it, and that's going to be negative 12x. Bring down the plus. Signs are negative 32 wins it. I had that adding the opposite, so it's the same thing as subtraction. Okay, pause. Let me give you your homework real quick. Do like the odds of the homework. I know you're not going to do all of it. Do the odds to check your Canvas keys. It's very important tonight. Thank you. Good night. Good night.